Okay, this video we talk about the exercise 5. How about if the structure, the carbon compounds with functional group and sometimes with unsaturation. And let's see how to name this compound. So if you look at the video here, so we will also again work out the name from right to left, right? Work this out. So we will try to find out, identify where we have the alkyl or alkyl acid group in the structure, and then we will then look at whether we have unsaturation, right? If we have unsaturation, we should be ENE, right? If there is saturated, no double bond, then that one will be ANE. But remember, if we have two things together, then we will omit E here. That means if you find functional group in the structure, then you need to omit the E here, the last letter E here, either from ANE or ENE, need to cross it out. Say for example is we have anole, we have anoic acid. We don't have anil. This is not easy to pronounce, right? Skip the E. And then if you have unsaturation, it will be enol or enoic acid. So four kind of combination. Okay, don't forget sometimes a double bond will need to count how many are there and also where they are. Where are they? Okay, so they need to count. Also, this functional group also need to do that too. The OH group, sometimes they will not be attached to the first carbon, so we need to also tell where they are, where it is, or maybe. Okay, then the other will follow the parent chain, the longest continuous chain. So use the prefix here if you count the number of carbon in the parent chain, and then we'll identify the side chain, the substituent. Okay, and then we can complete. Let's see the answer for the 6th example here. So first we identify this is the parent chain, right? Parent chain, and I see the functional group is OL, right? I highlight OL here. Functional group OH, not OL, so I say. And then no substituent. So what will be the name of this one? So it start with OL, right? Work out the name from right to left, and then it is ANE, alkane, no double bond, so anol. And then no substituent. Then I count the number of carbon in the parent chain. 1, 2. I should number the parent chain start from the carbon that holding the OH group. This is the carbon that connect to the OH group, right? So it's 1, 2, 3, and 4. Okay, so it's butanol. Okay, then next one. So I also highlight the parent chain longest. So the OH group is not carbon, right? Please don't highlight in this way. Some of the students will do this and it's not correct. Oh, this is include the functional group. I include the functional group. But the parent changes, we are talking about carbon. Carbon bond, not this. This is not a carbon, right? So your connection is wrong. So instead, we will draw the longest continuous carbon change from right to left, will be left to right, will be okay. And then the OH group will be attached to carbon number 3. OH group there, 4, 5. But no matter which direction you count, the result is the same, so don't bother, right? So let's see how to work out the name. So it's OL, but how many? 1. Where is it? At 3. So 3 OL. Okay, we do the same things like what we do with substituent, but we're working at the suffix. And then is it ANE or ENE? Any double bond in the carbon chain? no double bond, right? So it's AN. No E, skip E. So N thiol. And then the parent chain 5 carbon, so it's pentene. Okay, that's the answer. Then how about the question 3? The longest carbon chain including the carbon with the functional group. That means you should include this carbon. It is attached to the OH group into the parent chain. Part of the parent chain, you see? It is now part of the parent chain. So it's okay. And then I will number the carbon at the same time. 1, 2, 3, 4, 5. Like before, no matter where I start to number the carbon, either right or left, or right to left, left to right, will be the same result. The OH group will be still at third, right, carbon. So the name will be, you see, developed from question 2. So it's O. Where is it? How many? Only 1. Where is it? 3. And then any unsaturation? No. No unsaturation. AN. Parent chain, pan. But that's not the end, right? Pentane field. Then we need to highlight we have side chain. 1 side chain. Where is it? How many is it? And where is it, right? 1. Methyl. 1. This is a methyl group, side chain. And where is it? 3. So this is the answer, right? 3 methyl pentane thiol. Next, question 4. Okay, now include the carbon with the attached to the functional group. This is the carbon attached with the functional group result to COOH group, right? So I should include this carbon in the parent chain. Start from here actually. So even the numbering, I start from here to number 1, 2, 3, 4, 5, 6. Okay, now this one no substituent, and then let's finish the answer will be OH acid, right? The answer. So start from right to left. OH acid is the suffix of COOH. So let's check any double bond in the carbon chain. Only single bond, so it's NOH. So how many carbon in the parent chain? 6, right? Has NOH. And then any substituent? No. Then I rewrite it better, right? This is hexanoic acid. Okay. And then question 5. So again, first we include the carbon with the functional group. Actually, it is the functional group. So this is the beginning. We name it first, number it first. And then this is the longest continuous parent chain. So number the carbon 1, 2. We number the functional group as carbon number 1 now for COOH. It is the big boss. So 6 carbon. And then highlight the substituent, drawing a triangle. Identify them. Both are methyl group. And then later on we do it. Okay, like before, exit first, right? Right to left. Of course, if you are really good, you can start to right like before, left to right, like normal writing, right? But that need more skills. Otherwise, you make mistake. Doing this in this way will be more accurate. Okay, first suffix OH acid, and then position always 1. Only the first carbon can have this arrangement. So we don't need to asking about where, right? Because always the first carbon, right? No need. So then this is no double bond there, is NOH acid. And how many carbon in the parent chain? 6. Is this hexanoic acid, like before, like question 4, right? And then we have 2 methyl, not methane. methyl group, 2 methyl groups, so dimethyl. Okay, about the space of question 4. Dimethyl has a no exit. So where are they? Because we have fixed this carbon as the first one, because it is the functional group. So we don't have other choice. We have to number them, start from here. 1, 2, 3, 4, 5. It's 3, 5. 3, 5. Dimethyl has a no exit. Okay. I will write it again to make sure you see it clearly. Below her is 3, 5 hyphen dimethyl has an no exit, right? Okay, you get the answer. And then the last one. Last one is we build on something before her, but this one is new. So the parent chain include the big boss COH here, start from here, right? And then I think end here. Okay? So we can also identify the substituent, 2 methyl group 2 substituent. Methyl group. So let's name it. Number first. Give it number. 1, 2, 3, 4, 7. So always the big balls start from number 1. This means the COOH group. This carbon always will be the first carbon, number 1. So this one will be 3, 5, get a dimethyl like this one, right? Is it the same? Not the same. Right? Okay, let's do it. Finish it. I need more space, so I go here. Exit. OA. Saturated. AN. 7 carbon. Heptane. So it's heptanoic acid. Substituent. Dimethyl. Now in that space, I write it again. Beta. And then position 3, 5. Hyphen. Okay, we write 3, 5. Dimethyl heptanoic acid. Okay, after the exercise 5, I think if you know what to do and have it all correct, you are very good in writing the name of carbon compounds. Congratulations. Okay, see you again. Bye bye.